day to you all. You are welcome to the class today. And then in today's lesson, we're going to be looking at the second aspect of integration. We have considered indefinite integral. We are considering definite integral. And the objectives are, you should be able to understand the concept of definite integral. 2, evaluate the constant of integration. And then 3, you should be able to evaluate definite integral. Okay? So far so good, we have talked about definite integral as when you have integral that ends with constant c, as I told us. By each time we are integrating, we always end our final answer with c, simply because we are dealing with indefinite integral. And if we are to solve this one further, more information is required. What do I mean by more information? It's just like maybe a function gives us this curve, and we are being asked to find the area under the curve. We don't know where to start. We don't know where to end. That means there is still need for more information for us to be able to find the area under this curve. But unlike definite integral, integral that contains limits are called definite integral. What is the limit that we're talking about? You can see A, you can see B. I believe you are seeing this for the first time. This A, we call it lower limit. And this B, we call it upper limit. How do we apply that here? The lower limit is that point here. Then the upper limit is that point here. So if we are to find the area under this curve now, between lower limit A and upper limit B, it is very easy. And how do we do that? We just find the area from this point to this very point. Let's say it's 40. We find also from this point to this point, let's say it's 10. Then to get from here to here, we say 40 minus 10, which will give us 30, and that is what we want to do. Now, how do we evaluate definite integral? We have about 4 steps. And what are these 4 steps? Number 1, find the indefinite integral as usual. Okay, once you have succeeded in doing that, move down to the next step, which is you calculate the value at the upper limit. What do we mean by that? After you have gotten your integral, definite integral, replace your s with upper limit there. That will give you f of b plus c. Don't forget your constant c. Then calculate the value at the lower limit, meaning that you are substituting your x, a for x. That is, you are replacing x with a. That will give you f of a plus c. And then once you have done that, just like I told you, you are subtracting the value at this point from the value at this point. So you are now subtracting the value at the lower limit, which is f of a plus c, from the value at the upper limit, which is f of b minus c. And you will agree with me, this c will cancel this c. So we are left with f of b minus f of a. So it is now important to note that each time we are dealing with definite integral, the constant c is always omitted. How? Because when we subtract, the c will nullify each other. Okay, let's just have an example on that. We have to find the definite integral of the function 4s cubed plus 1 ds from 1 to 3. How do we do this? Like what the step says. The first step is saying we should what? Find the indefinite integral of this. That means we have integral of 4x cubed plus 1 dx. This will give us, applying our method of integration, we have 4s to the power 3 plus 1 over 3 plus 1 as usual. Then plus, when integrating this is the same as 1x raised to the power 0, because x does not appear, means the power of s there is 0. Then we have plus 1 over 0 plus 1. We need to put plus c, but like I told us, we are dealing with definite integral. So we should have this to be 4s, 3 plus 1 will give us 4 over 4 plus 0 plus 1 will give us x over 1. Okay, and at this point now, we need to now replace our x with the upper limit, replace our s with the lower limit. So by the time we do that, we are going to have, when we substitute x as 3, substitute x as 1, then we are going to have this to be 4s raised to the power 4 over 4 plus x. Of course, x divided by 1 will give us x. From what now? 1 to 3. which will give us, now let us have this x replaced with this. That will give us integral of 4 s raised to power, okay, 4 will nullify 4. If 4 nullifies 4, so that we won't waste our time doing that, 4 nullifies 4, we are left with s raised to power 4 here, then plus x at what point now, when s is 3, minus the same thing, s raised to power 4 plus x at when s is equal to 1. So we can have s equal to 3. So let's replace s with 3 here. This will give us 3 raised to power 4 plus 3, still in bracket, then minus, this we are replacing with 1. 1 raised to power 4 plus 1, still in bracket. So we have this one, 3 raised to power 4 should give us 3 times 3, 9 times 3, 27 times 3, 81. Then 81 plus 3 should give us, I think, 84. Minus 1 raised to power 4 will give us 1. Plus 1 will give us 2. So we have 84 minus 2. And finally, 84 minus 2 will give us 82. I believe this is so simple and straightforward. Just few steps and you are done. So other examples will be sent to you as notes in your Google Classroom, and make sure you feel free to ask as many as possible questions you want to ask based on this video. Have a nice day. Bye.